Look, this is a very complex trial, 4 trials we had over the last 3 years, and I'm going to apologise to all the groups in advance in that 3 years of data, 4 trials, that's 12 years worth of data, 10,000 hours of work by these guys and Murdoch. I can only present so much in 15 minutes. So I'm going to focus on productivity and carbon, which is what the original focus of the project was all about. I will point out that it was funded through a round that got released by the Department of Agriculture, State Government of Western Australia, and we've got Nathan Mercer over there in the corner, and I went in hand and cap to Michael and asked the other 30% so we can get the project up and running, and then we formed a team with Murdoch and 4 other grow groups, and I think it's been a really good example of researchers learning from farmers, farmers learning from researchers, and the interaction of how we can work together in a funding model going forward. So why chase funding for carbon? We know it's really difficult in Western Australia to sequester carbon in our cropping systems, pasture systems. It's mostly sands, low buffering capacity, low biomass. We have droughts. Soil carbons go up and down like yo-yos. We haven't really been trying to historically, we've struggled to sequester carbon. So what can we do differently in this environment to try and push that a little bit further? So just before I go there, project team, mentioned before. So we got Luca Di Pietro, the program leader, Richard Bell, fantastic oversight research. We wouldn't be able to do this without him. We've had Luca Di Pietro, many of you know, followed by Dr. Hassan Sadar, who took over for that role. We've had Nathan Craig and now Simon Kruger overlooking this trial. Chris O'Callaghan from the Levy Group, Veronica, and now Joy Valley from CFIG. And Dr. Kelly Pearce started off with, and now Tina is doing a bloody good job in getting this data together. So approach, what did we do? We went through the literature and had a look at what wasn't working, and then we kind of narrowed it down to, okay, what haven't we had to go at? What haven't we tried in our sandy soils to actually try and sequester carbon and increase biomass? There are some existing technologies around soil amelioration, and people have been talking about organic amendments and inorganic amendments like biochar for a long time. Haven't really got it working yet. So what we did, we chose 4 different methods to test. Increase carbon through continuous input, plant-based solutions, increase buffering capacity, looking at biochars and so on, slowing the microbe breakdown of carbon through things like biochar, and increasing carbon through organic amendments. We use manures and frasses in this case for the trials. And probably more importantly, we look at the combination of all those factors. So trials, we had 4 sites, Belaring, Quita, Wathingarra and Dwallingu. You'll see 2 of those sites tomorrow. They're still going. The funding finished last year, but we got more funding through the federal government to keep these trials cracking on. I'm going to present 3 of the trials. The Levy Group site had 2 really bad droughts the first couple of years. We had trouble getting clay and other things to the site. So we'll focus on those 3. And I'm going to jump straight into the data. A lot of it is trends I want you to focus on rather than... we've got 30, 40-page reports of each of these trials which will be published on the site, CRC site at some point. Just at Quita site. So Quita is what we call an OFE scale. So it's on-farm experimentation using farmer equipment and farm scale. So all of these plots are 200 metres long. And then we kind of use farmers' gear to deep rip, to add the amendments, and then to harvest. So what we found just quickly in the first year, where's backwards? What we found in the first year is that we got a really good response to yield in some of the amendments. So going from control, that's Bednar, that's the ripper we used. That goes to about 40 centimetres depth and is designed to mix the soil a little bit. So it's got a bit of a scoop down the bottom of the tine there to mix some soil. We had some sea-wise, we had a carbon amendment. Then we used gypsum as well as the Bednar. and then we had a combination of gypsum, bednar, and the organic amendment. So we didn't get much benefit out of the organic amendment, probably at the rates we're using, maybe a little bit low. But we certainly got a big response to ripping, which is not unusual in that country. We're kind of expecting it. The big advantage we got was adding gypsum. We suspect, and we should explain this better, maybe aluminium toxicity, pH issues down at depth. So we found that in the first year, which is very encouraging. That was barley. Fast forward to last year, which was canola. Kind of got the similar response, but non-significant. So some of those effects were wearing off after the third year. So that could be, that could be due to canola being less responsive to some of the treatments we put in. The canola's got a very deep taproot. Maybe it's sourcing nutrients and water differently than a cereal crop. Or it could be that some of the effects of the ripping and so forth are beginning to wear off. I'm going to ignore that we have about 10,000 pages of soil nutrition and plant nutrition I could go into, but I'm just going to focus on the carbon. You will notice the graphs here from left ABC is 0 to 10 A, 10 to 30 and below 30 centimetres. That's tonnes, total organic carbon in tonnes per hectare. So we sort of converted the organic carbon levels into tonnes per hectare. We have in the first two surfaces we declined in carbons as a general rule of thumb, and we had a slight increase as a general rule of thumb, including the control at depth. We see this a lot in continuous cropping systems in our soil types, that carbons is high yielding the last 3 years. We're taking a lot of carbon off the paddocks. We're not replacing that carbon. And so we're seeing a decline in carbon even though we've put all those amendments in. Not overly surprising. The depth one, it's non-significant. Maybe something there at depth. Maybe the roots are getting down at depth and sort of getting a lot more carbon down there, but a bit too early to tell at the moment. Okay, fast forward to blowing. And there's a couple of slides I think we're missing out of this, but maybe that was my fault for not catching up with Olivia. But this is design. Blowing was a continuous input into plant input, so plant solutions. But what we did there, we combined the plant solutions in with deep ripping again and claying. We added clay to this site. What's missing in the slide was we had, I think, organic carbon levels of 0.4 in the topsoil, 0.4%, going down to 0 in the lower levels. So I did have a picture up, but it's extremely sandy inert soil. So we're trying and make differences. In the first year, keep stuffing up. First year we got a response in the barley to claying and the bednar, really big responses to yield there. In the pasture, in the crop mixes, we did get a biomass response, not shown in this graph. And then in the by year 3, once again, those treatments tend to wane off a little bit, similar to the previous trial. And the carbons, interestingly, I won't go break down into all the individual treatments again, but generally speaking, we did get a bit of an increase at depth again, a bit of a scattergun at the other two levels. The ones at the top there tended to be the plant-based solutions trials. We tend to go slightly more carbon than the continuous cropping trials, but again, the significance is a little bit dodge, and the increase in carbon at depth again, which is interesting. It's fairly consistent between sites. Okay, quickly on to the Wethengara site. How much time I got? 5 minutes. Wethengara trial. This trial is so complicated I won't even begin to describe the actual treatments. It was a historical trial that had amendment after amendment over 2 years. We got this funding for the 3rd year, and we put on other treatments on top of that. So some of the trials have had ripping, some of them have had biochar, some of them had all sorts of treatments. And so a bit tricky to go into specifically the treatments. And frustratingly enough, when we go out in the paddock, you can see differences in biomass and look like we're doing great things out there. Statistically, didn't see much when the data came out. There really wasn't much in it. That's a compost. That's the rotary hoe with the biochars and so on. We didn't really get a massive response to yield or biomass in those sites. We did, after the first year, we decided, because the farmer especially wanted to go into pasture. So we had development in there from 2023-24. So it's been pasture the second 2 years, which leads us on to the carbons. Probably the only site where we're showing a trend to increase carbon. We put that down to the pasture input, legume input, which in the literature we see a little bit of. So we were putting our legume pasture in, a really good legume pasture. You won't see it tomorrow, it'll be back in crop this year, isn't it? Yep. So if people go to this site, but interestingly enough, particularly at the 10 to 30 and down at depth, there's not much significance between the treatments. Interestingly, it's more of a pasture species effect. So conclusions. Yield responses found with amelioration, adding organic matter, adding inorganic amendments, particularly in the first year. They tended to decline over time, which would indicate at these sites you may have to reapply or redo some of these treatments every 3, 4, 5 years. And that does happen in the wheat belt for ripping, for example. Soil types up north get ripped every second or third year because it's a responsive soil. Adding organic matter could be expensive every second or third year, but it could be a case of accumulative effect of adding organic matter every 4 or 5 years could accumulate. The trick is to get that stuff to depth. What we're seeing is the carbons are increasing at depth. Getting the carbon to depth is the trick, where the amelioration combination comes into play. Baseline, what I didn't explain in previous slides, the baseline carbon levels started between 5 to 12 tonnes per hectare and then went up to 20 tonnes in some situations and went down to almost nothing. So some of the carbon stories is the variability in data really made it really confusing to make any simple conclusions, except to probably say, as we kind of expected before, continuous cropping systems is really hard to sequester carbon in our environment. And it's probably not a methodology that we could probably hang a hat on at this stage to actually put a carbon credit in for this kind of response. Saying that, the trial's been refunded for another 4 years, I think, 3 or 4 years, maybe 4. We're going to reapply some of these treatments. We've got more sites across Australia, so it'd be interesting to come back in 3 or 4 years' time to see what's happening. Pasture species, I think certainly the winner in trying to increase carbon. And growers are using these techniques already. They're using clay. It costs them a lot of money to use clay, but they're getting a return on that investment for 2 or 3 years. And that's certainly a way of increasing the buffering capacity of our soils. And I think we knew from the start of the trial, and we told Lana Martin and the state government, 3 years is not long enough to do a carbon sequestration project. But productivity-wise, there's enough in there, I think, for farmers to take away that the stuff they can put in will get a response. How often they have, the big question for them now is how often they have to come back to actually keep reapplying those inputs over time to sustain that productivity. So the economics haven't been done on this. So any economists want to join the team. One other thing we didn't do, we're using carbon as a sort of indicator for soil health. We've taken all sorts of nutritional measurements I didn't go into, but anybody wants to come along and do soil microbial measurements, I think that'd be awesome to go forward for those trials that got refunded. So I'll finish there. Thanks.